that we have to consider, okay, to achieve the best possible power output. So yesterday, as we discussed, to design any engine, two major criteria to be noted. First one is when it goes to any consumer, that is the buyer. Okay, he will look after, he will shortlist the first item is the efficiency. Whatever may be the grade of the vehicle, maybe it may be at the smallest segment vehicle or a very posh vehicle. So the first attitude of a buyer will be is to look after the efficiency. If efficiency of the engine is very, very poor, 90% of the consumers will not plan to buy that vehicle. Okay, so there should be an optimum power output at a higher efficiency. The second is to get the authority approval for the sale of the vehicle. Okay, the vehicle or the engine has to satisfy the emission norms. Currently in India, BS6 norms are prevailing. So while designing, the designer has to keep in mind about the regulatory authorities that is maintaining the emission norms of the engine as the first point. Second is to develop the best possible power and give the best possible efficiency as output. Some of the factors to be considered for that we have discussed yesterday. Okay. So next we started with supercharging. What actually is the supercharging? In simple words, I can say whatever the charge you are giving. Say, for example, in case of diesel engine, you will be giving air. In case of petrol engine, you will be giving air fuel mixture. So that charge will be supplied at a higher pressure. That is called as supercharging. You use an additional equipment to pressurize that, increase the pressure and give it so that higher efficiencies can be achieved. Right? So some of the advantages and limitations of supercharging and some of the notable points about supercharging we had discussed. And also we discussed about different types of supercharging arrangements. First one was supercharging of engine by a compressor, directly coupling the engine to a compressor. This we had completed. The second is supercharging of turbine driven by exhaust. So this is one of the most effective method. So the exhaust gas, whatever is there, that will be used to drive a turbine, which in turn drives a compressor. So that here, so in the first mechanism, as we discussed yesterday, there will be some amount of power loss. Yes, you can see there is a gearing arrangement over here. Here, you can see a gear arrangement over here. Directly, one of the shaft of the engine is coupled to a compressor. So whatever power developed by the engine is there, a part of the power will be utilized to drive the compressor. Remaining part will be used to drive the vehicle. Okay, so we can consider it as a part of power drop. But what happens is, as we discussed yesterday, when you give the pressurized charge as input, the efficiency of the engine will be higher. Okay, I quoted an example also. If 20 points of the or 20 units of the energy is used to drive a compressor, there will be an increase in efficiency by 40 to 50 units. So net output of the engine will be higher if you calculate. So this is the first mechanism. Okay, so the second is much better than this. If you ask why, okay, so here we are not using any engine power to drive the compressor. The compressor is driven by a turbine, which in turn runs on the heat energy available from the exhaust gas, which otherwise would have directly gone through the silencer to the atmosphere. Okay, all I can tell you in simple words, the waste heat of the engine is used to drive a compressor, which in turn will help us in increasing the pressure and giving the pressurized charge to the engine. So whatever 20 or 40 concept we discussed here, no question of any units of energy from the engine is used, but there will be a net increase in 30 to 40 units of power developed. So this is a much better mechanism. That's the first one. So this we had discussed yesterday. So coming to the third, supercharging the engine by turbine compressor, which are coupled with each other. Okay, so just take down the sketch. I think we had stopped at the second one. This is the third one. We'll give you 2 minutes. Please take down and let me know when it is done so that we can go ahead. Is it done? Varun, Chetan, Akshay, Sumit,
Yes, sir.
is it
Yes, sir.
done?
One minute, sir. 1 minute.
Okay.
Done, sir.
Okay. Okay. So this is the third arrangement of supercharging. Okay. So wherein the engine is coupled to the turbine is coupled to the gearbox or through a gearbox to the engine. Part of the power is used to drive the turbine. The output of the turbine is in turn connected to the compressor. Okay. Compressor in turn takes the charge from the inlet. Okay. It may be air fuel mixture or air. Okay. And that will be given through a intercooler to the engine. Right. So this is the mechanism. Okay. So here one of the point to be noted is here the turbine will run based on the exhaust gas given plus the gear mechanism both. Okay. The part of the power required to drive the turbine is given by the engine itself directly, and other part is given by the exhaust gases, waste heat. Okay. So that the efficiency of this system increases. But the problem is when you use a coupled device like this, there will be some amount of losses. Right. So this is the sophisticated and superior mechanism as compared to the first two, whatever we discussed. So this is the third arrangement of supercharging. Okay, same thing is discussed here. Okay. And the fourth arrangement here, please make a note of it. Fourth arrangement, take down the sketch. See, this mechanism is also called as free piston engine, okay, wherein the total power of the engine is used to drive a compressor. Okay, compressor in turn gives a pressurized charge to the engine, and the engine output will be used to drive a turbine, okay, on which a load will be applied, and you will be taking the output over here. Okay, so this is entirely a different mechanism, okay, wherein total power is given to the compressor. Compressor is useful in producing a better charge to the engine. Engine output is used inside a turbine to give the required mechanical energy. So this concept is called as free piston engine. Okay. So these are the different types of supercharger arrangements that are used. Okay. So usually reciprocating compressors, displacement type rotary blowers, or centrifugal compressors are used for superchargers. So just we were discussing about the different arrangement. In that, a compressor is one of the important component. So this type of different types are used. If engine crankshaft drives supercharger, then it is called as mechanical supercharger. If the supercharger is driven by a gas turbine which runs on exhaust gas, then it is called as a turbocharger. Okay. So in the engine specifications of any car, if you see the words turbocharger will be frequently used. So we have seen the arrangements also now. In some cases, engine crankshaft itself will drive the compressor. In some cases, okay, the exhaust gas driven are there, which is more efficient. Okay. So if the engine crankshaft drives the supercharger, then it is called as mechanical supercharger. If the exhaust energy or waste heat drives the compressor, then the entire mechanism is called as a turbocharger. Okay. There are different types of superchargers. One is the centrifugal type, second is the roots type, and the third one is the vane type. So far we discussed about arrangements. Now we will be discussing about the different types of superchargers. The first is the centrifugal type, second is the roots type supercharger, and third is the vane type. So first we will start with the centrifugal type supercharger. Okay, please take down. So this looks almost similar to a Francis turbine that you have studied. Okay. Please make a note of it. So this is the very first one, that is centrifugal types supercharger. So it is commonly used in all automotive engines. It consists of an impeller. Okay, so this is the impeller with the diffuser, whatever you can see. This part is the impeller, that is a turbine-like structure, usually which is made up of alloy steels. Okay, and it rotates at very high speeds. Okay, so the limit of speed may be around 80,000 rpm. Okay, at very high speeds it rotates. Okay, so this impeller is closely or tightly packed inside a casing. Okay. So the air enters axially, similar to Francis turbine, whatever I told you, the air enters axially at the center of impeller. So this is the center portion axially, in the axial direction, the air enters at an angle of 90 degrees into the impeller due to centrifugal action. Okay. Due to the centrifugal force, it will be pressurized number of times. Okay. It passes to a diffuser and then it comes out to the main casing. Okay. So through the diffuser arrangement, it comes to the main, and here the compressed air will be coming out. Right. So due to the centrifugal action, whatever high velocity air from the tip of the vanes which comes out here. Okay. So what happens? The velocity gets converted to pressure as the volume increases, and high pressure air or compressed air comes out of the this supercharger, which will be directly entering into the engine. So due to the entry of high pressure air, you can pump in 30% more air and fuel mixture into the combustion chamber. Due to the high density, complete combustion takes place. Okay, so that actually is the concept. So axially, the air enters into the compressor. It will be due to the centrifugal action, it will be compressed. So when it comes to the diffuser, it gets further velocity is converted to pressure. So the high pressure air enters into the induction valve, into the engine. So this is the working of a centrifugal type supercharger. Okay, so same thing is explained over here. So you can clearly make note of few important points, like you can say the highest rotation speed around 80,000 rpm. That is the main part. So at that such high speed, okay, when the air is subjected to high centrifugal forces, okay, high velocity will be the output. This high velocity air, because of the diffusion, gets converted to high pressure. So because of this mechanism, you can achieve 30% more air and fuel mixture can be loaded, which leads to better efficiency. Right? So please make a note of it. So you need not write pages together. A proper sketch, okay, with important points is more than enough. Okay, so we'll move to the next type. So before that, there is a video you can go through. Construction working, you can clearly see in this. complete arrangement and working you can see in this video. You can see the working now. The input is given from the compressor. Okay, so we'll move to the next. Roots blower, that is second type. Or it's also called as roots supercharger. Please take note. This is the roots type roots blower or root supercharger. So this acts like a gear pump. It is similar to a gear pump. Okay, and consists of two epicycloid rotors. So these two are the rotors. Instead of a wheel, you can see two gears are there. Okay. Each of them are keyed to the shaft and housed in a common housing. So this is the housing of both the gears, and they are keyed to a common shaft. These rotors are connected together by means of equally sized gears, and both of them rotate at the same speed. Okay. At inlet, air enters. So this is the inlet. Air enters, okay, in the space between the rotors. and elliptical housing. And when the rotors keep on moving, the air gets compressed, and because of the pressure difference, when they come at this point due to high pressures, it will try to move out. Okay. So it is a very simple and low cost design. It has very highest possible mechanical efficiency, and it is always suitable for low and medium speed applications. But the first one, whatever we saw, it was up to 80,000 RPM high speed applications. So this type of rotor is not suitable for such, supercharger is not suitable for high speed applications, but this has an advantage of highest possible mechanical efficiency.